John. I'm a student at Tulsa Tech in the Motorcycle Watercraft program. And today we're going to test the starting system on a 2009 Suzuki GSXF. We have removed the fairings from this motorcycle and have identified the switches at the wiring harnesses and taped them accordingly. Okay, I'm going to test the battery source in the unloaded state with the key ignition off. I'm going to set my voltmeter to volt DC. And I'm going to put my positive lead on the positive post of the battery, my negative lead on the negative post of the battery. We have 13.25 volts DC. Okay, now I'm going to test the loaded state of the battery. By doing that, I'm going to turn the key ignition on, turn my headlights on, my hazards, and press the brake lever. My voltmeter is set in volts DC. I'm going to take my positive probe to the positive post of the battery, my negative probe to the negative post of the battery. We have 12.35 volts DC. Electrical starter systems are found on motorcycles that use a DC motor to transform the battery's electrical energy into mechanical energy, to turn the engine's crankshaft quickly enough to start the engine. The amount of current required for a starter system is very high. Therefore, a starter solenoid, also known as electromagnetic switch, and heavy gauge electrical leads are used to make this connection between the battery and the starter motor. The armature shaft inside the starter is connected to a gear reduction system, which multiplies the motor's torque. This enables the starter to turn the engine over rapidly under pressure. Once the engine is turned over, the excessive RPMs disengage the armature shaft. This is a starting system for our motorcycle. It is an in-series parallel system. Our battery is grounded. Our red and black wire goes through the 30 amp fuse, through the ignition closed, into the black and orange wire, through the fuse into the turn signal side stand relay. This is parallel, is that it'll go through the gate, through the diode, through the blue wire, the gear position switch, which indicates if it's in neutral, to a ground. Through the relay as well, after it goes through the gate, it'll go through the green wire, through the side stand switch closed, through a diode to ground. After completing through the gate, it'll go through the blue-black wire, through the engine stop switch closed, through the black and red wire, to the starter button. Once the starter button is pressed, it closes the circuit, goes through the blue-black wire into the starter relay. Through low voltage, the relay is activated, closing the circuit for current to go through the black and yellow wire to the clutch lever position switch. Closed, it goes through the black-white wire to ground. Once through the starter relay, current goes to the starter motor, starts the engine on the ground. Okay, now we're going to try to start the bike. Turn the ignition on. We have a no crank situation. Okay, we're now going to test the ignition switch. We've traced the wires from the ignition to the wire harness. We're going to plug one lead into the black-red wire and one lead into the black-orange wire. And the key off, we should have an open lead as identified on the voltmeter. Turn the key on, please. With the key on, we have resistance of 0.2, 0.3 ohms. We're now going to test the engine stop switch. It's identified by the black-blue wire with one lead and the black-red wire with the other lead. With the engine stop switch off, we have a reading of open lead. With the engine stop switch on, we have a reading of 0.3 ohms resistance. Now we're going to test the starter button, identified by a black-red wire and a blue wire with a black tracer. We have open lead, and once you press the starter button, we have a reading of 0.3 ohms resistance. Okay, now we're going to test the neutral switch, or the gear position switch, and with it in neutral, we have a reading of 0.1 ohms resistance. With it in first gear, we have a reading of open lead. All right, we're now going to test the clutch lever position switch. We've disconnected the black wire with the yellow tracer, the black wire with the white tracer. We have one probe on each terminal. We have a reading of open lead in this position. Squeeze the clutch. We have a reading of 0.1, 0.0 ohms resistance. Okay, we're now going to test the starter relay to make sure that it's getting power from the battery. We have our voltmeter set in volts DC. Put one lead on each opposed terminal. We have a reading of 13.12 volts DC. Okay, we've now tested all three switches and they appear to be good. They read good. So the last thing to test is your 30 amp fuse in the starter relay. With the voltmeter set to ohms, put your leads to the fuse, and we have a reading of open lead. Fuse is bad. We have replaced the bad fuse with the fuse that's good, put it into the starter relay, and we've got our voltmeter set to ohms, and we have a reading of 0.0 on our fuse. So now we are ready to try to start the bike. Ready? We're going to now try to start the bike. We tested the switches in the starter system, and we have found that our problem was a blown fuse causing the no crank situation. We've replaced the fuse with a good fuse and have successfully started the bike.